Alrighty, let me pick up the chat window and participants. Who's here? All right, thanks everyone for coming today. This is our weekly data structure workshop. We're going to be going through 3 problems tonight. They're pretty basic problems. They're easy, are categorized easy by LeetCode, and none of them are require a huge amount of code to solve them. So we're going to start off with reverse string. So that problem entails taking in a character array and then reversing that array, and then I believe it's we don't even have a return. We just have to reverse the array. So then we're going to do remove duplicates from a sorted array. Again, only one array. We're just going to look through the array for duplicates, and we'll get rid of the duplicates in that array. And then we're going to finish off with kind of the toughest one. Not really that hard, but relatively speaking, between the 3, which we'll be taking the longest substring from an array, or maybe from a string, sorry, without any repeating characters. All right, so if you go to LeetCode.com and you click on problems, and we're going to, first one is reverse string. And it is problem number 344. It's easy, and I believe all of these problems today fall under one category, and we'll talk about that category when we get to it. And so of the times it's been tried to be solved, 69.1% have been successful on what do you call it, solving it. And then the other, what is that, 38.9% of the time when people have submitted their answer, it's been incorrect. So it's not it's not the easiest of them all, but it's not very difficult, mind you, either. All right, so we're going to click on the reverse string. All right, and this is our first problem. But before we get there, because we have a new person here tonight with Emily, don't mean to call you out, Emily, but I just want to share with you our framework that we are trying to use to get through this and through these problems. So it's a 6-step process, starting with understand, and this is molded around kind of the technical interview. So you'll see interviewer a lot throughout the concept of UMPIRE. Also on the event tonight, there's a link to a little article about it. And then I have more information that I can link you to as well. So first part to understand. So the biggest thing under understand is, do we fully understand what the problem is that we're trying to solve? Do we know what the inputs are? Do we know what the outputs are expected to be? Do we understand any edge cases that might be involved, such as if we're taking in this case, a array of characters, what if that array is null? What are we supposed to return, if anything? What if, for example, we're dealing with numbers and we come across negative numbers? How do we deal with that? How do we work the issue of capitalized letters and small letter and lowercase letters when we're talking about working with strings, those kind of things. Try to make sure that anything that could disrupt our problem, we kind of identify before we even start thinking about a strategy of how to solve it. All right. The second piece is match. So this is where we're going to try to match problems that we have come across before with the problems that we're seeing currently. So in your data structures, i.e. programming 3 and algorithms and so forth, you'll come across certain problems that, in this case, Dr. Yang will go through and talk about for hours on end. But you get a good baseline of what some of these types of problems are and how they kind of work. So when you see other problems, hopefully you can recall what you have learned in class, and then also what you've learned on your own. Try to match up the problem that you see with a problem that you've done before, or something very similar to that you might have read about or was talked about in class. That way it kind of gets you on the right track of how you're going to start thinking about solving this problem. Okay. So then we go into our planning stage or our pseudocode stage, where we actually either write out pseudocode or we write out comments, however you are most comfortable with writing out kind of the framework of how you're going to actually solve the problem. So once you've done the pseudocode and everything looks the way that you believe it should, then you can start to implement. What the plan, match, and understand steps are hopefully going to get you to get to is that when you actually get to implement, you should just be able to go ahead and code everything straight out in a matter of minutes without having to kind of go back and forth and trying to remember how to do X, Y, and Z. That the pseudocode and your comments have kind of already created that framework for you, so that the coding piece is, done very, very rapidly. And, this whole framework, I guess, is that those first 3 steps are going to end up being the majority of your time to solve a problem. All right. Then the last 2 steps, review and evaluate. So you'll review your code, make sure everything is working the way it should. As we go through these problems, we'll take it. If we have time, if it's that complex, if you don't fully understand how everything's working, we'll go and we'll run it through the Python tutor Java side, and we'll watch step by step as the compiler goes through each line and how our variables change value, and how all of our loops and everything else are working, and hopefully working in the correct manner. All right. And then finally, the evaluate. And this comes down to that big O and the big, basically the big O, both on the space side and on the time side. So when you start thinking about how much time the processor is needed to run for your program to actually compile and complete, versus the amount of memory that is required for your program to run, compile, and then spit out its data. So if you're not familiar, this is the Big O cheat sheet. Put this in the chat. So this is a big programming 3 and then into algorithms, of course. So if you don't remember, or if you're like Robert, who hasn't taken programming free, then you can kind of start thinking about all the common data structures and what their expected big O's are, whether it's searching through an array, inserting to an array, deleting from an array, or searching through a hash table, whatever it is, and then your sorting algorithms and stuff like that. So it's not an all be all, but it does get you kind of thinking about how each of your little pieces are going to work against each other. So first string, I don't want to see my solutions. No. I'm going to move this over to the side so you can't see my solution. All right. So what we're going to do here is I'm just going to take this information from the description. I'm just going to copy it over. I'm going to go over to our repellent. Now I can bring this back over. Oh, I know that was Ray because he always does the bebop. Paste our information in. Okay. So this is a pretty straightforward example or process in terms of the fact that we're taking in an array. We don't have to have any output, which makes it a little bit easier for us. So we are in a void method. And the key here is we want to do it in place. So when we talk about doing it in places, we want to use the same array. We don't want to use another array to create extra memory space. So we want to keep it all linear if possible. So what we're going to end up doing is just, I mean, we're not going to obviously be able to do inserting and going through an array because we have to access and insert. So we're actually going to have to go to ON. We're not going to be able to stay at O1 just because of the way it is. But in terms of creating extra space on the space side, we don't have to create any extra space except for maybe one or two variables so that we can actually save the information that's in our array. All right. So we can start here. Right? Does anyone have any questions on this particular problem of what it's asking and what it's outputting? So our inputs and outputs, for example, we have hello. So we have 5 characters that go in looking like hello in the array. And then when we spit it out, it comes out as OLA, you know, as the output. And Hannah, we don't have to change because it's a palindrome, but we do have to change it at least because we have the capital H that has to get swapped over. All right. So as we talk about this, does anyone have any thoughts of any times where we may encounter an issue with accomplishing this task? Any arrays that might hamper us, whether that's null or something of that nature? You can speak up or in chat, that's fine. So what if we had an array with only one index? So all we had is one letter. Can we solve that quicker than trying to swap out? or if our array, of course, is null. So maybe we have the base case in there that says that, if we don't have, if it's less than 1 for length, then or 1, or if it's less than or equal to 1 in length, then maybe we can just return whatever at that point. We don't have to worry about going through the entire process. Does that make sense? So as an example, 3 input for example, and we know the output should be I. So now I'm going to call out Ray because he should know this, I hope. So Ray, if you were to match this up with any other problems that you've done before, what type of algorithm would you match this up with?
I would just do it for what?
If you said 2 of something?
No, yeah, the 2-pointer.
Yeah, 2 pointers. What's 2 pointers?
When you start at both ends.
Or you don't have to necessarily start at both ends, but you take 2 pointers and you go across an array.
Yeah.
So in this case, how would we work the 2 pointers?
I think you just move them, like if you start one from the far left and one at the far right, and you just move them closer to each other.
Okay. And then we just swap out as we go through?
Yeah.
Okay. All right. So we do 2 pointers. So with 2 pointers, what are we going to need? What kind of data structure in there?
A for loop?
Okay. Or at least a loop. So doesn't matter which one, but a loop. And then in the loop, what are we going to do? So if we have a pointer on the left-hand side of the array, so at index 0, and then at a pointer at the other side of the array, what's going to happen? How are we going to move them? And then what are we going to do to reverse this array? Right.
Well, I guess we would have the pointers represented as integers of the index.
Right.
Closing my door. Hold on.
Okay. Hope I'm not disturbing Grandma's dinner tonight.
No, grandmother's not here. So we'd have the 2 pointers represent integers, or the index. So one would be like 0 and it just increase, and one would be the length minus 1 and that would decrease. And for every time that the number, after every time that the pointers are set, we should swap the characters at those pointers. And then after we swap, we add to the first and subtract to the last pointer and just keep squeezing it.
Okay. Can you repeat it again? You broke up on my side.
So we would have 2 pointers. We'd set both pointers first.
Yeah,
and after we set
that part is just the left.
after we set, then we swap them, and when we swap them, we subtract the first pointer and we add to the first pointer and subtract from the last pointer. So that way the first one moves up and the far one moves down.
I can buy that. All right. So as we go here, we talked about the for loop. So when do we really want to stop this loop?
Once it gets to the middle.
Okay. So what are some of the ways that we can stop it? Let's compare the two loops that we know between a for and a while loop. How will we set up a for loop to do that, and how will we set up a while loop to do that?
Break.
Break where?
In the middle.
How do I know I'm in the middle? How do I tell
when
you?
it's when I guess if if either pointers reaches the length divided by 2, like Emily says.
Yeah, okay. All right, I can buy that for the for loop, so that I would be less than the length divided by 2. Does that make sense? So I starting at 0, going to the halfway point, and iterating up for a for loop. So something like that.
Yeah. Well, what about, does it matter which pointer it checks?
Well, I mean, with a for loop, your pointer, the easiest way is just your right pointer would be I, and then your other pointer
Okay.
would be J, and you just start J at the length -1, and then decrement, right?
Yeah.
So how would we do the same thing for a while loop?
While I is less than s dot length divided by 2.
So how about even easier than that?
While true.
Well, of course it has to be true. But let's think about the 2 pointers. Do we ever want the 2 pointers to cross? We're like the Ghostbusters. We don't want the streams to cross. So at what point?
If left pointer or starting pointer is greater than the right pointer, or if they equal each other.
So which pointer is greater than?
The left one.
The left, starting from 0,
Yeah.
is greater than the right one, starting from length?
Yeah.
Okay. So then we've crossed at that point, haven't we?
Yeah.
So how do we not cross? You're close, but what if we just do I being from the right? I mean, I being from the left and J from the right. As long as I is less than J, then we're good, right?
You could just do R and L for left and right. While right is less than. Oh, I see. Okay.
Or actually, no, it should be very confused. Because you
While
want,
left.
because you don't want left to cross over right, right?
While left is less than right. Yeah.
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 So
Or while do we also have to do the other condition while they equal each other? Because if it has like the same letter or no? Not worried.
we'll still get that. It just won't.
Okay.
Yeah. Well, we don't even have to. We don't have to do it. You know why we don't have to do it? Because it'll be the middle letter, and we don't have to replace it with anything.
But where would it go?
It stays where it is. So if you have a 3-letter word,
Oh yeah, because we're swapping. Okay, never mind. Yeah, never mind.
yeah, we don't have to. We don't have to do it. Okay. All right. Which do you think is going to be preferable to do?
What?
Which one is better to do? The while or the for loop?
Well, the for loop creates one of our values already, and we could just replace left and right inside the for loop, and I is our left. No.
No. I just want, if you remember in programming 3, remember how
I don't.
remember how she used to have us count all the operators?
How she what?
Had us count the operators?
Count the operators?
Yes.
Oh, hold on. Do that. Say it again.
How she used to have us count the operators to determine the ON, the big O, the big O.
Yeah.
Yeah. So how many operators does the for loop have versus the while loop?
1.
So which one's better?
But we're still gonna have a lot of operators if we do it outside.
Well, I mean, we're still going to have other operators, but the for loop or the while loop, which one is better to use?
I guess the while.
The while. What I'm saying is because we only have the one operator, we don't have to deal with the multiple operators in the for loop. So we'll save, we're not going to save a tremendous amount, but we'll save a little bit.
But I thought the only operator that counts in the for loop is the plus plus. At the far the whatever keeps it running, the cycle.
Well, no.
Or is it the I less than?
It's the less than 2.
Okay.
Because that stops it.
Okay.
So you're always doing the less than, plus now you're doing the divide by, plus you're doing the incremental. So we're still gonna get away. We're still gonna have to have the incrementer, but we won't have to do the divide by. So we'll save a little bit there. And we're still also gonna have to have a decrementer in both, no matter what we do. All right. So 2-pointer approach. We'll go for a while loop. All right. So let's talk about our variables. So what type of variables we're going to use?
Decimals.
No such thing as decimals.
Ints, integers.
Integers, okay. And you want to go left and right?
Yeah.
So our first one equals that. So the S, which is our array length, minus 1. All right, so we have our 2 there. We'll construct our while loop. All right. So how do we swap? How many lines is it going to take for us to swap? Can we swap straight on? Can we take and put the right into left and left into right? So I'll give a resounding no, we cannot. Because otherwise we're going to lose one of them, one of the values if we are trying to swap straight on. So we're going to need to create a another variable to temporarily hold one of those values so that we can swap. So our type is character because that's the values from our array. I'm just going to call it temp for the window. So we can take either one. So I'm just going to start with, let's start with the right. So we're going to go S, right. So, oh, I don't need a dot. I'm doing too many dots today. So we're taking our index from the right, so that's from the far side, and we're sticking it into temp, our character type holder. All right. And then so now we'll take, we're still use the right here, and then we'll take from the left and put the value of the left into the right. And finally, we'll take the left and we'll equal that to the temp value. So right goes into temp, left goes into right, temp goes into left. Kind of like a snaky thing here. I know it's kind of easy to mess up. That's why the order of things there, right? And then we have our left, which started at 0, so we have to increment to go up. Our right, which started at the far side, and we're going to decrement down. All right. We can, of course, run this now. Let me. Yes. Let me start with the right. No, it's not going to work. Make me work for it tonight. All right, so now we have characters and not strings in there. Right. Then we'll system out print. And call reverse string. Yes. We'll run. Uh-oh. Oh, because I did strings. What is that? First string, character S. Did I need to keep it doubled up? What the hell? Okay. I guess I'll take out the void. Yeah, no. I'll put those back as strings, and I shouldn't have. What the? Oh, return type. So I can't put void, but I can't print. I can print F. No, you can't. It doesn't return a string. We haven't built a string. Oh, you just want to return S? In that case, you have to. Well, I totally busted it. Oh, you already did. Okay. As I went to a whole new window and stuff messed up. Okay.
Is
So
string
what's that?
is string builder faster, or not string builder? String builder reverse faster?
Yeah, but we're not using a string.
No, but you can convert a string or a character array to a string.
And then you have to do other stuff to it. So
I don't think so.
you still
I
have
read
to.
it in a book. Don't worry. Hold on. I want to see. Don't worry about me.
So what y'all can do is outside of this return S. So you can take this part up and you can copy it over and you can put it in your LeetCode if you want, if you have an account already, and paste it on in. You can have completed your first your first problem. How you doing on October challenges, by the way, Ray?
Oh, I haven't done them.
Yeah.
I've been doing the medium questions on Java on
Yeah.
LeetCode. Actually, I'm probably going to start when class starts tomorrow.
Okay, so that's our first problem. What's our time on here? Actually, this is the difference right here on between this first one was a for loop, the second one was a while loop. So I actually saved 0.6 megabytes from going from a for to a while loop. My runtime wasn't great. So there's quicker ways that you can do this, but I went from memory. I wasn't quite up to the memory stack. But also here in discuss, you can go in and find solution Java. No, it's the same thing I use. Pythons. No, so this is a little Python here, but yeah, I guess you just swap it that way too. But doing the pointers. Yeah, everyone has the same 2-pointer idea. Who's got 100% on Java? That's what I asked in this point. Either way. So that's our first problem. Just want to shut this tab down. All right, our second problem. What's our second? So remove duplicates from an array. I think this is like on the first page. No. Maybe not. Oh, I haven't even done this one. Look at that. All right, I'm going to create a new one of these. Wow, there's a lot of stuff in here.
Leo, what is the link that you use for
Oh, yes.
checking? No, the link that you use for the Python link that you use to compare.
Oh, okay. Yeah.
Because I got it working.
Okay.
I want to see how fast it is.
Python tutor, Java tutor. You want to share?
What?
You want to share
Share what?
your screen?
I can. I cannot.
Oh, do I need to stop?
The other participant. Screen.
So hit Java tutor up on the up above.
Oh, whoops. No, yeah. Oh.
What did it?
It did it automatically. Which one is it? So I would just copy these two, right?
Oh, you want string builder out. It's not going to tell you how much faster it is.
Oh, it isn't?
No.
Well, wouldn't it be easy to tell by the amount of steps it takes?
Oh, it could be, yeah.
Yeah.
You probably have to comment out line 11.
Symbol. Why, wait, cut out line 11? Oh. What is this? Okay.
What did it return? Did it return your beep back?
Yeah. Yeah.
Did you return it reversed?
Yeah. Exclamation mark peeb.
Oh, up on top, yeah. So does that satisfy the memory of O1?
I don't know. I don't know how the memory is of
So did
string
you do it in
builder.
place? Did you do it in place in the array?
Did I do what now?
Did you solve it in place in the array as per the directions?
Wait, sorry, say that again?
Did you solve the problem in place based on the directions in the array?
Oh, I don't know what the speed is of the string
No,
builder.
it's got nothing to do with the speed. It's the memory adding. You're not
Oh,
supposed to.
I mean, I don't know how expensive it is to create a string builder object on a string. I don't know how much that costs in memory.
No. Well, you wouldn't have solved the problem anyways because you didn't solve it in place.
Give me this.
Line 5.
But I don't have another array.
But you built a string, which is another array.
But not technical. Or...
Technically, it's an array. It's actually a heap, but
A string builder is an array, I would say.
that's a heap. Strings are heaps.
So not an array.
Yeah, but you still created another data structure.
But it doesn't say data structure. It says, never mind.
Heap is another data structure. Even though heap doesn't take a whole lot. All right, so removing duplicates. Man, there's a lot of directions in this one. All right, again, we're not line 4. We're in place. Nothing crazy. Which means it's going to be pretty simple. Basically, the 2-pointer method again. For return values is an array. passed in by reference. So given numbers, and then there's an output of an integer. Okay.
Is that the right link? Because I can't get into it again. It keeps taking me back to the home page and not actually bringing me into your thing. Yeah. There you go.
Oh, now you're yellow. First length elements. So internally, you can think of this: numbers passed by reference. Blah, 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 blah. So the length. Okay. All right. So the return thing is the key piece here. So we need to return an integer, and that integer is the times that I guess the amount of times we iterated through, both of them iterated through, that would seem to be.
I think it wants the new length of the array you modified.
Yeah. Okay. So if we go through it, and then we take out what we need. Okay. Yeah, I think we could do that with one of the pointers. So using the 2 pointers, how would we do the 2 pointers in this time? Last time we started one from the far side, or from both far sides, so from the left and the right. What would be the effective way to do this since this is sorted? I should probably bring in my chart in. Can't do my Snapchat. Yeah. So since everything's in order, if we were to have 2 pointers and we started one at 0 and one at 1 and then moved up incrementally in that manner, we can check, because we're only checking the ones next to each other. If they're the same, since it's sorted, we know that we need to remove it for them, right? If they're different, we're just going to keep moving until we find the ones that are the same. So if we go up to the example here, so do we have, I don't think I can do like a reverse cat, but let's say I have pointer 1 will be my hashtag, pointer 2 will be my %, and so we'll compare the 2 pointers In this case, it's 1 and 1. So if they're equal, we'll remove one of the two, and then we'll shift up to 2, right? So then we'll move up to this way, and then we'll know 1 and 2 are not the same, so then we'll be fine. So we'll end up with 1, 2 as a result, and the length being 2, because we no longer have to worry about the ending. All right, so when we talk about length, so we started with the one that started 0, and he's going to go up. We cannot go beyond this. So our right hand pointer in this case, which is the n plus 1. So n starts at 0, n plus 1. N plus 1 can never go beyond the length. So the length will stop when we get there. So if our guy here, this guy gets short 1, right? Short 1. So if he's short 1, and we add 1 more to him, I think that we could get the length from that, I think. The new length. Because he moved up to 1, so he's value 1 right now, which is now 0, if you will. But the length is 2. So him moving 1 plus 1 might do it. So let's so if we go here, he strikes him out, then we move, then we move, we strike him out. So he's moved 3 so far. Oop. So he's up to the 4th. And he's up to the 5th. Go to 6th. Cross him out. Go to 7th. 1, 2, 3, 4, 6, 7, 8 is a 9. That doesn't make sense. So he's 5. But has he moved the whole time? Oh, maybe he doesn't move until. So all those 2s that we had, so we had a bunch of 0s. We had some 1, oh, and we had some 1s. We had 2, and 3. So if he starts here, and we delete him, I should say, and he goes up, everything's good, and we move him up, he just goes here, we delete him, he increments up, delete that one, he increments up again. Now he's now online. Now he's gone up to the 2nd, so he's up 3 right now. He gets cut off. He increments. It's 4. If we cut him off, he increments up. So we're up to 1, 2, and he's up to 4. plus the last one, which is 5. So we have to move them separately. We can't move them totally together. So the first thought process would be nested loops to move each one, but how else could we do it without having to do nested loops? Because we only have to move the guy on the right-hand side if we have to, right? And we don't have to, but we do have to move the left one every time. So we can either do that with nested loops or maybe even an if statement inside the loop. The two variables for the pointers. We don't need to save anything because we're just going to delete out. We need a loop. We need to move pointers. I'll change that to pointers instead of variables so we can remember. Remove duplicates in here. We're just gonna have to figure out in the loop how we move everything here. And the other thing would be is if we have, let's say we have one array in here or one entity and we have our 2 pointers. So we're at 0 and plus 1 and we only have a 0 index. What's going to happen if we try to run it through that loop with a plus 1? You're going to end up with out of bounds exception. So we're going to have to probably have a so if we only have one indice or one index, kind of sounds weird both ways. There's only one index in the array, then we cannot put it through the loop. Otherwise, we're going to get out of bounds. And then we have to remember that we have to turn length. I'm just going to put 0 here for now, just a placeholder, so nothing yells at us otherwise. All right. So what do we need to return if we're at 1? If we're at 1 or 0. So if it's null, we have to return 0, and if it's 1, we have to return 1 for length. So we could either do an if, else if, or we can just do 1 and just return the length that equals 1 or less, right? So if So there's nums dot length. Just do less than 2. And then we'll return nums. So if it's less than 2, where we know we can actually throw it into the loop, then we can just return the length. So if it's null and 0, then we'll return 0, and if it's 1, then we'll return 1. Because there's no duplicates in either of those, so we can just return the normal length. So we need 2 pointers. I'm just going to do slow and fast. So we'll start with +1, quote unquote, for the faster one, the one to the right. Does that make sense? Hopefully Ray doesn't get mad because I did slow and fast.
No, it makes sense. It's not I or K or alpha.
I's and J's and K's are the way of coding better.
What makes no sense. Whoops.
Get used to it. All right, so the fast one can't go, so fast has to remain less than the length, right? So we can either do it as that or less than and equals to length minus 1. Make sense? So as we kind of stepped through the process up here in example 2, we left our slow guy back as we ran through and found duplicates with the fast guy. So if nums dots, not dots, sorry, nums fast is not equal to nums slow, then we can move slow, right? Because if they're equal to each other, then we need to knock them out. And then in this case, then, if they're not equal to, which means they would have been either equal to beforehand, then we should probably then swap out here. So then nums slow becomes nums fast in value. Because we're not necessarily deleting it here, because what we want is, so when he gets to this point, and they're no longer equal to each other, because the first one was 0. So So increment up, and then that increment will become 1, that value. And then he'll increment up, and then we'll find 2, and he'll increment up, and then 2 goes there. You follow my logic. I hope my logic is sound. So we need duplicates to be here. So that's in the if statement. And then so while is going to be our fast guy moving. He'll go up. So he'll keep iterating through, and we'll stop. The fast will stop when the slow and the fast are different numbers. The slow will move up to the next indice, and then what fast, the value of where fast is right now, will then be replaced where slow is, which is 1 up from the last non-duplicate. And so since slow is going to take a while, but he's going to go all the way up to, he should go all the way up to the second to last one, right? No matter what, he's always going to go all the way up. Because even if there's duplicates in there, they're all going to get deleted. So it's slow plus the 1 should return our length. Because he's always going to be 1 behind in the overall. And we can't say fast, because fast is going to be the length of the old array. Slow is only going to go as far as the new array, but not all the way to the end of the new array, because it will never reach the last one to it. Oh no, it'll reach the last one to it, but it will never reach beyond it. So we'll get, slow will have traversed the full length, but we'll still need to add 1 on there because it started at 0. If it started at 1, we wouldn't have to, but we need that first index. Hopefully I didn't lose anyone when I threw all my logic. Give me some crazy stuff. Oh, because it's not static. No. Thank you, Robert. Typed in the wrong spot. 5. So we end up with 1, 2, 3, 4, 5. So 0 to 4. You want to put in another case, Robert? As long as it's story. It's kind of easy to pull the answer out of that one. So 10, 1, 2, 3, 4, 5, 7, 8, 9, 10. Yeah. I'm gonna steal the code. Stick it here on my all right, hopefully we met all the cases. Oh man, look at that, Ray. 100%. We're fast, but we're not perfect on the memory.
Dang.
So that can be one more that you solved. This last one. Oops. Oh, number 3. Oh, we're on a medium one. Sorry, look at that. This wasn't so bad. It's a new one. Oh, I missed Emily leaving then. All right, Emily. There's the last repellent, so you can go back to it. This is recorded too, so it'll be on YouTube and probably tomorrow. This is one of the problems we had to do in class. So. All right, so we have a string, working with strings. All right. So then we have to find the longest substring without repeating characters. Okay. It makes perfect sense on this second example of bees. And the ABC and the PWK. Or WK. Oh, because it's not a substring. Okay. So it's WKE. So the P and W are not a substring. And you can look up the difference between the subsequences and substrings. But suffice it to say, the substring is combined and has unique characters. And because the PWWKE, because you can't just have the PWW because it's so the real next substring is the WKE. You might say PW, but it's not the longest. The WKE is the longest. Okay. All right, so because I said that we're doing 2 pointers all the time here, we're doing 2 pointers. Nothing surprise there. Everyone understand what the problem's asking? We're taking the longest substring, and that's why we get the WKE in example 3 instead of just PW. And we have ABC twice over in example 1. They're the same length, they're the same characters, so we only have the unit for 1, and the length is 3. And then, of course, all the B's, and since it's without a repeating character, and we only have 1 character for B, everything else is B's, so it's only 1. All right. May have to cut this a little short. Hopefully we can finish it up because I got a lab at 7 o'clock for programming fundamentals 1. All right. So, yes.
Wouldn't this be like the same we did in the previous one, except we'd be changing the starting pointer every time that the next number is not the same, or the next character is not the same?
It is, but because we're not in an array, it's a little bit more complicated than that. And because we also have to compare. So, for example, in the third example, we have a couple substrings. We have P and W, and then we have WKE and KEW, really. But because KEW or WKE is before KEW, that's what we're going to return. But it's longer in length than PW. So we have to keep track too of how long all the substrings are so that we return the maximum length one. that make sense? Right.
Sorry, no, my mother just came in.
Oh, okay. So we have to keep track of the longest substring. We can't just, you know, call them out. We have to keep track of the longest one, because the longest one is what we need to return. So if we were to like spell out the alphabet, what's the longest substring without a repeating character? It'd be 26 because there are 26 distinct letters in the alphabet. So what we want to do is we're going to have to compare the the letters to each other, get everything to be able to compare each one to each other. We could do that in a loop, or in this case, I think the quickest way would be to do it in a hash set or a hash map. So we would load the contents of the string up into a hash set of characters, and then we'd have the keys and everything to then compare to and get the right lengths. Does that make sense? Maybe, kind of. So because we have example 4, we have to, we can take that into account first. So base case, if string is null or one character, then we can just return the length, right? Because it's only one. Class. Probably need some variables in here. Because we do have to return an integer where at least probably a result. And we're probably going to have to keep track of how long our subarrays are. So then we need a loop. To fill the hash sets. And then we probably want to do something in the loop too of keeping track of longest set or substring. And then probably want I think that's about it. And then we'll return It's going to be, I think the loop's going to get complex. Return a int result. Length of substring. All right. So let's start. We can do an if statement. So the if this is null or s length. We have the parameters on there. No, to 0. Show 0, and then we'll return 0. So I think if we put it in the loop, I think everything will be good. Because I think we could probably use a for loop here to make stuff easier for us. A while loop, I think, can get a little crazy. We call hash set. Now we have characters. Let's call it set. Hash set. And I have to worry about putting characters over there. So then we need just call first one result. A result to print out. And I think we're going to need to keep count of, yeah, we'll need to keep count of the, so results will be that'll be our max, essentially. Then to count up our substrings, we'll use another one, which is count. So we'll do our for loop. 0, nothing crazy here. We'll go up to the length of the string, last length. We have our parentheses in there since this is a string and not an array. And we go plus plus. All right. So we're going to use a temp here to collect our character. That's char at I. So now we have to go and we have to take the character and we have to put it into our hash set so that we can save it up and do our comparisons. So if, what do we call it? Set contains temp. Okay, so that's going to be not. So if the set doesn't contain temp, then we'll put temp in. So temp dot add, oh, I'm sorry, set dot add temp. So we add the temp in, and then we're going to result will equal math max of results and oh, comma. So that will be set size, right? Size. So we're gonna keep adding in the characters as we go through the string. And if they're unique, we're gonna add them to our hash set. And once we are no longer, and we're going to keep adding, and we'll add the first one, so result will become 1. We'll go through again. So for example, we hit number 3, so we'll get it up to 2, and then we'll fall out of the if statement. So we are going to do an else. So else, oh, we're going to have to nest, we're going to have to nest it. Because we want to, if it goes to C, we want to count up. And we need to count until it's above I, right? So while count which is 0 is less than I, then we're going to count up here. But we're only going to count up if they match up. So if sets no, it's S for the string. So if count equals to 10, then we'll count it. And we'll do that. I think we're going to have to break out of it. And if not, then we're going to remove the character count. All right, so what we're doing here is, and we'll count up. So if we have what we're doing is we're filling up our hash set in the if statement. So we'll fill it up, and we'll get our result, we'll reach whatever point is for that particular substring. But in order for us to use that substring again, we're going to have to empty it, empty out that hash. So if we're not unique, we're going to empty it out basically. And we're going to keep a count of all those characters and keep removing, basically remove them out until we get back up to I. Okay, so we're using count as basically J, if you will, for, you know, an inner loop, inner for loop. Basically now removing everything out of the hash set that we put in so that we can make room for the next substring to go into. And so we can count out the substring. That makes sense. So we'll clear it out, and then we'll, once it's cleared out, then we'll go back to the for loop and start filling in again, and then dumping it when we need to. All right. And then result will be returned, because we're always we're always maxing out the length of our substring. So no matter how long the max length of our substring is always going to be captured in result here. So I'm not going to bother trying to do a thing here. Substring. I'm going to come on over, capture this all, paste it in, nothing in correctly. To anal on my tabs. You guys can run this through PyTutor afterwards if you want, but my time is limited, unfortunately. So so we'll do the else, we'll remove everything, and then we'll return the results. I think I have an extra one here. So I'm just going to run the code here and check my sub cases. What I missed here? Oh, character. So 3 on the first one. Let's do the second one. Test case. We'll replace the string with B's on that test case. I get 1. Replace this test case with test case number 3. On that one, you get 3 again. And then I'll run empty. And I should return 0 right off. Where my cursor go? Yeah. And 0, okay. I'm going to submit. All right. So we're not bad on our speed, and we're pretty damn good on our memory. Right. So basically, what we did is we built the hash set. We iterated through our string. We added to the hash sets, and with every unique substring of that string. When we finished that substring, we went into the else. We removed everything from the hash set using the count in this case, which started at 0 and went up to right before I. So once we got out of that while loop, then we went up and continued on. Then we went to our next substring. Okay. Any questions? No.
I have a lot, but yeah. I mean, it makes sense when you're talking through it, and then I don't know. I feel like I just like need to like go through it, but slower.
Yeah, I know. I'm sorry. I gotta run over to
Yeah.
a class and which is about to start. Um, yeah, if you remind me, yeah, next week we can take a couple of minutes to go through it
Okay.
slower at the beginning. So I'll do 2 problems next week, and
All right.
we'll walk through this one. All right.
Sounds good.
Yeah. Thanks for coming. Thanks everyone else for coming. You're the only one here, but
Yeah.
all right. I'm gonna stop recording.